Thank you. So I'm from chemistry down here, and my name is Craig, and this project is based on my dissertation for this year. So what is it about? Well, we're using Roman history to teach this field of heritage science and chemistry to school pupils, but first we'll do some history. So the Roman Empire, probably didn't know about them. They lasted for over 1,000 years, and during that time they really enjoyed pigments. Like, pigments was big business for them. So they were mining pigments across the empire. So from Spain all the way up to Britain, they would be mining pigments and then transported to Rome. An example would be vermilion, so really deep red, sort of like the Let's Talk About X red, that were derived from the mineral cinnabar and then taken to Rome under armed guard. That was then used in paintings and wealthy houses, and also actually as a primitive form of lipstick, which, because it was mercury based, had a lot of health implications. Another thing is, it was mined in a place in Spain called Almaden, which is still there, and the mine is still there, and that is Arabic for metal because it was mercury based, so the metal mercury. So a bit more closer to home is the Antonine Wall. So if you don't know about that, it was here in Scotland from Old Kilpatrick out to Bridgeness in the east. It's about 37 miles long. It was primarily to divide the south, which was controlled by Rome, and the north, which was uncontrolled by the Caledonians. And now any of the sites are under the control and preservation of Heritage Scotland. And as it says, it's one of UNESCO's World Heritage Sites. So there's a quick map of it. We can see where we are is where the Hunterian Museum is. So we're sitting pretty close to that. So as you can see, it's absolutely massive, this wall. It was built in about 12 years and then abandoned about 8 years later. So they weren't here for that long, but in that time they managed to build this absolutely massive wall, which is quite amazing for the time there. So we have a quick video showing of what it's like now. So here we take off from about halfway along the wall and head out to the end of the wall, which was the last bit to be finished. So here we have the likes of Grangemouth and the Falkirk Wheel, which were on the map. This is the last quarter of the wall, so this would be the bit that they finished last. And then they headed out towards now where Grangemouth and the Forth bridges are. So the 3 bridges out there is roughly where the wall finished. It actually finished in the small town on the left coming up, and we will come on to that next. So when they finished the wall there, they placed something to commemorate that section being built by them, but what exactly was it they placed? So they placed what's known as distance stones. So what are the distance stones? Well, these were stones placed by each legion to mark the lengths of the wall. So one legion, Legion A or Legion B, would mark the bit that they built, and then they would then put this inscription in a stone, chisel it into a stone with some images, and give themselves recognition for building this. But the important bit is the pigments on the images was what they decorated them with. So they had text in the middle, images at the side to decorate these stones. Generally, pigments and the stone was sourced locally, so they would have used anything that was nearby, dug it up from the earth, and placed it on the stone. The stone was then placed into the wall, so it could then face into the empire for prosperity and propaganda. So an example of a distance stone, this is the one that was found in Bridgeness, just at the end of that video. The text tells you which legion it is and for which emperor. So this one would be the Emperor Antonius Pius, who was the Roman emperor at the time, and it tells you the paces. So at the very bottom, it's 4,652 paces that distance was about. But you can see that there's images on the left and right of the distance stone. So these are where the important stuff comes. So here is Bridgeness. The red dot is where the stone was found, and to commemorate that, there is now a replica there. There's also a replica in the Hunterian just over there. So if you want to go and see it, it's there. And in 1867, it was dug up, and it's now in the National Museum in Edinburgh. So I do chemistry, so why am I telling you about all this Roman history? I'm not really a historian. So we, as chemists, you probably think we sit in the lab with lab coats on, doing loads of experiments that don't work. But we don't always do that. So if we divert a bit, we can discuss the actual pigments themselves. So if anyone knows what a pigment is, if we go basic levels, it's in terms of the same way the grass is coloured green, is because we remove all the light that isn't green, we remove all the light that isn't green and we're left with green. So here, if we have a red pigment, it'll absorb the green light and then leave us with red. So you just go across it. So we can already see that we're starting to become kind of chemistry because we're talking about what pigments are in a chemistry context rather than something that's pretty colours. So where's all this leading? So it's into heritage science, which is a new field of research that spans both all the arts and all the physical sciences. So you may have heard of conservation chemistry. So conservation chemistry is in heritage science. So we're between chemistry and art. So we're not in both. We need to use both to solve certain problems. So in a nutshell, it will use science to preserve and protect for the future, the past for the future. So if we have an old artifact, we can analyse it and protect it and preserve it for the future. But we don't need to just preserve it, because if we already know how to do that, that's quite boring. We can also time travel. So if we analyse it, we can, for the distant stones, reimagine what they used to look like. So, for example, the Roman statues we all see now as white and bare and boring, but back then they would have been decorated with all these lovely pigments and brought it to life with the skin tones, the lipstick for the vermilion, etc. So we can reimagine what they used to look like by using chemistry to analyse these. So we can go from this boring old stone, which one we saw before, the bridge nest stone, to this, where we add in the colour back to it. So we have the reds on the Romans, we have the skin tones on the horse and the Roman soldier, we have the blood on the head, the person below, and we can reimagine it if there's pigments present that we can analyse. So what did I do with this? Sadly, I didn't actually do this research, but I used this research to use it as an idea for making something that we can roll into schools. So we can teach schools about the power of heritage science, and chemistry isn't just sitting in the lab doing boring things with a lab coat on. So we can use that and design a teaching pack that teaches people this. So ours was based around being given some data here, so it's almost like detective work. You're given some fingerprints and you have to work out who did the murder, but except we are working out which pigment it was instead, on which stone. So why did we do this for school pupils? I mean, it sounds like doing something for nothing, but the skills they used and the chemistry they learned is going to currently support their curriculum. And not only this, it teaches them about heritage science. So at an interdisciplinary conference, we know how important it is to show interdisciplinary skills. So we teach them this early in school rather than they get to uni and learn it. So we start teaching them it way before that. And most importantly, heritage science is a new research field, so we can promote it through this. So the response we got from them, we only tested it on one school. It's hoped that we can roll this as a whole unit or a teaching pack out to schools. They really enjoyed it, so all of them said they'd like to do it again, and I don't think that was just because they got a day off school, but they did enjoy it, hopefully. And the comments they left were really, really positive to us. They were split into groups to do these problems, and I think the most powerful bit of the teaching pack was they felt more confident about tackling unknown problems. So we gave them something they had no idea about, completely new chemistry, and they broke it down into concepts, and using the archaeology and the pigments, they were able to work out what they needed to do. They all said that they understood why chemistry is important in heritage science. So again, that's more teaching, because before it, they never knew what heritage science was, and if they, based on the feedback, and if they thought of chemists, they thought we were all just the same people in lab coats. But they were in their final year at school, so they're going into uni, and it's important that if they want to go and do chemistry, they don't just need to do chemistry, they could do something else to then enter heritage science as a chemist. Does anyone have any questions?